An ordinary annuity is a device that we use. We invest money, we do it monthly, and we have an equation, the ordinary annuity equation, which will tell us if we are investing at a certain rate and a certain amount each month, it'll tell us how much we'll have at the end of a certain length period. It's a little bit complicated. Things are compounding. Typically, how would we use this? We're given an interest rate. We just know we can save, I don't know, $500 a month from our paycheck. Oh, wouldn't that be nice? And in 10 years, how much will we have saved? The annuity equation will tell us that. Here's the annuity equation, ordinary annuity equation. There's other types of annuities as well. I guess we're not addressing them in our class. What's different in this equation? We have future value, we have rate, we have M and M, the number of periods, interest compounding periods per year, and the total number of compounding periods. R is the new one, and that's simply our monthly investment. Let's do a problem. This is rather complex, and it gets into that log operation that you saw in your textbook, and a couple of you asked me about. Okay, we have a future value of, in this problem, they kind of twisted things around, and I pulled this one right off our mastery exercises. That's okay. We had a future value of 7,000. Let's see, we're giving, putting in $250,000 per month. Our total future value after a certain number of months is going to be 7,000. Let's see, I didn't write down a rate. Let's say we have a rate of 9%. That's an annual interest rate, just like always. So the question is, how many months, how many compounding periods is this going to take in order to turn that $250 a month into 7,000? Well, by definition, M is the number of compounding periods per year. But by definition, when we have an annuity, we are putting it in monthly. So the number of times we invest per year is 12. We don't know N. That's the only thing we don't know in this equation. Let's plug in our values and see what we get. How am I going to do this and show everything at once? It's going to be tough. It's okay. Okay. Here's our future value equation. Future value equals, bad start. Future value is 7,000. It's equal to R, 250, times the quantity, 1 plus R over M. Let's see, 9%. Move 2 decimal places to the left. That's 0.09. Divided by M is 12. Minus 1, oh boy. Just made it. Divided by R over M. R 0.09 over M12. Oh boy, that's tough to see. Did I do this one? Yes. Okay. Well, right away I can move that 250 over to the left-hand side by dividing both sides by 250. And when I do that, I'll have 7,000 over 250 is equal to, now I can start doing some work in here, 0.09 divided by 12 plus 1. Oh, I forgot to raise that to a power, didn't I? I sure did. And what is N? Oh, N's my unknown. Yeah. So let's see. I can calculate 0.09 over 12 and add that to 1. And that will give me 1.00. Where'd you go? 75 raised to the n minus 1 over 0.0075. Yes, that 1.075 and 0075 are different by that 1. That makes sense. Okay, I'm trying to isolate that n. This is going to be an interesting one. Now what can I do? Well, to get rid of this 0.0075 in the denominator, I can multiply both sides of this equation by 0.0075. That'll cancel the 0.0075 from the right-hand side. And so I'll take and rewrite my 7,000 over 250 times 0.0075 is equal to 1.0075 raised to the n minus 1. I'm getting there. What do I need to do now? This is multiplication here. I now can combine these terms, and I can get rid of this minus 1 by adding 1 to both sides. It will get rid of the 1 on the right-hand side. I just have to do the same thing to the right side, add 1 to the right side. Let's see, when I do this math, I'm going to have, well, I'll take it a step at a time. First, I get 0.21 equals 1.0075 raised to the n minus 1. And when I add 1 to both sides, I get 1.21 equals 1.0075 raised to the n. Okay, now comes the logarithm part. There is a rule of logarithms that you can take the log of both sides is a legitimate operation, so we will do that. I'll take the log of 1.21 is equal to the log of this number that I've said a billion times, 1.0075 raised to the n. And now that I've done that, logs have an operation. If you have the log of a number raised to a power, that power can come out front and be multiplied by the log of the number. So now I'm going to slide another piece of paper underneath here. Move this all up. Pull the sheet down. There we go. So what I can do is say log 1.21 is equal to n times the log of 1.0075. And now this log is multiplied by n, and so I can move it to the other side by simply dividing both sides by the log of 1.0075. So I have the log of 1.21 divided by the log of 1.0075 is equal to n. There we have it. That's our answer. But how do you evaluate these logs? What are logs? Well, I'm not here to teach you what logs are. I suppose we could if somebody really wanted to. They're interesting things. They're quite handy in mathematics and trigonometry and calculus. Let's see. How do we use them? Well, we have a button on our calculator, and that button is the log button. And by the way, if you don't have a scientific calculator, you can, let's see, Windows has a calculator that has a log button in it. You might have to go to the options and find the scientific calculator, but it's there. I've used it. So what I do is push my log button, 1.21 divided by log button, 1.0075, and if I did that right, I get a wrong answer. Isn't that interesting? Let's try that again. Oopsie. Let's start over. The log of 1.21. Oh, I see what I did. Yeah, I got to put a closing parentheses divided by the log of 1.0075 equals, there it is, n is equal to 25.51. And let's see, what is n? N is in months. It's the number of compounding periods. In annuities, we pay it monthly. We have 12 compounding periods per year, so n is in months. Now we're going to have to round that up to get the answer that we had in the book. In the mastery exercise. N is 26. It'll take you 26 months to take your to build up to $7,000 by putting in $250 per month into an ordinary annuity, paying you 9%. Whew! Thanks, folks. I hope that helped. That's my last video for tonight. I appreciate the feedback you're giving me on these videos. It makes me want to do more of them because I think it's helping you. Let me know what other problems I can do for you. Call me, write me. I'm here for you. Bye-bye.